Welcome back, everyone. Today, we are stepping right into the martial arts dojo of academic success. We are here to tackle what is, without a doubt, one of the absolute highest stakes modules in your entire syllabus. We're talking about Cambridge AS and A-Level Computer Science 9618, and we're zeroing in specifically on the notoriously challenging Instruction Groups Input and Output of Data module. Now listen, we're going to be breaking down some serious past paper strategies today. We'll be looking at concepts that you've probably seen echoing across all your foundational codes, 0417, 0478, 0983, 0984, and 2210. All of those foundational building blocks, they've been leading right up to this advanced 9618 level. But here is the core concept we are adopting today, and I really want you to visualize this. You must flow like water. It sounds simple, right? But it's incredibly powerful. You need to be able to adapt your analytical style to absolutely any question the examiners decide to throw your way. I don't care if it's a completely unfamiliar weird context or a deceptively simple input and output trace table. If you can flow, if you can adapt to the shape of the problem, you literally cannot be broken by a difficult paper. So grab your notes and let's get into the mindset of a true strategist. Look at the screen right now and just consider the sheer weight of this statement. This isn't just a tip, this is a classified, insider warning straight from a Cambridge senior examiner. It reads, mastering instruction groups, input and output of data is essential for Cambridge Computer Science AS and A-Level success. This topic appears in every examination series. Okay, let that really sink in for a second. This isn't one of those fringe topics that might show up if you're unlucky. No way. It is an absolute certainty. It is completely unavoidable. If you walk into that exam hall without a watertight strategy for input and output instruction groups, you are literally leaving guaranteed marks on the table. You're giving them away. But don't worry, because today we are going to crack open the examiner's mind. We're going to show you exactly what they are desperately looking for, so you can walk into that exam hall with total confidence, knowing you are fully 100% prepared for this exact scenario.
Now you might be wondering, how do I actually win at this? Well, to understand how to win, we first need to take a hard look at how students typically lose. Let's analyze a real Cambridge computer science past paper question scenario. We're referencing both the historical 9713 and the current 9618 standards here. This scenario brilliantly illustrates our two struggling student personas. Check out the left side of the screen. We have Alex. Now, Alex is a hard worker. Alex has studied for months, but the second Alex gets into the exam hall, panic sets in, and Alex completely overloads the answer with raw computer science facts. We're talking a massive brain dump of every single thing Alex knows about input and output devices. But here's the catch. There is zero analysis. None. On the right side, we have Sam. Sam's problem is different. Sam is constantly fighting the clock. Sam rushes the response, just trying to get words on paper, and completely misses the specific command word requirements of the question. So what happens to both of our hardworking students? The examiner's dreaded red pen comes out. Both Alex and Sam lose massive marks. And here's the real tragedy. It's not because they don't know the technology. It's because their strategy is fundamentally flawed. They aren't flowing like water. They are rigid, crashing violently against the rocks of the examiner's rubric. We are going to make sure that doesn't happen to you. To fix that, here is our tactical briefing agenda for today's explainer. 1. Essential core principles. 2. The procedural framework. 3. Critical evaluation mastery. And 4. Top examiner warnings. Let's dive right in.
Section 1. Essential core principles.
All right, the absolute most crucial point you need to understand is the academic benchmark required by Cambridge. The assessment framework heavily prioritizes analytical depth over superficial breadth. What does that actually mean for you? It means if you write 5 surface-level sentences just listing facts about a scanner or a temperature sensor, you are going to score significantly lower than a student who writes just 2 sentences, but those 2 sentences demonstrate a deep-connected conceptual understanding of the specific unfamiliar context given in the question. Top-performing candidates do not just list facts like our friend Alex, they use systematic analysis, they use evidence-based reasoning. And this is exactly where we introduced your new best friend, the Peel framework for your extended answers. Point, evidence, explanation, link. It's like a martial arts combination. First, you make your point about the input or output instruction. Bam! Second, you provide evidence directly from the scenario they gave you. Third, you explain the technical mechanism behind it. And finally, you link it all the way back to the command words requirement. That, my friends, is how you achieve true, undeniable analytical depth. And applying that Peel framework brings us to a massive, game-changing secret weapon, the method mark strategy. The Cambridge syllabus strongly emphasizes that marks are awarded for the procedural, analytical process and your evidence-based reasoning. Let me repeat that because it's absolutely crucial. Even if your final output calculation is wrong, or your final conclusion is slightly off due to some silly little arithmetic error, if your logical, structured reasoning is visible on the page, the examiner can and will award you method marks. It's like partial credit on steroids.
So when you are formatting your very next answer, I want you to visualize this. Can the examiner clearly see your step-by-step logic? Can they immediately spot your Peel framework? If your brilliant process is hidden inside a giant, messy, unstructured paragraph, you are going to lose those marks. You have to make your thinking visible.
Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 2. The Procedural Framework.
Okay, grab a pen, because here is the exact computer science success blueprint. This is the definitive 5-step procedure you absolutely must execute when you're staring down unfamiliar contexts involving data input and output. Step 1. Deconstruct the question. What is the command word actually asking you to do? Is it telling you to evaluate, describe, or implement? Those all require totally different approaches. Step 2. Extract relevant data. Pull out the specific variables, the raw binary representations, or the data structures explicitly mentioned in the prompt. Step 3. Select your analytical framework. This is where you pull out that Peel structure we just discussed. Step 4. Execute with clear notation. Whether it's an algorithm or a trace table, write it cleanly. Don't make the examiner guess what your handwriting means. And Step 5. Present with terminology. Listen to me on this one. Do not use vague, everyday words. You must use the precise, high-level technical vocabulary required by the 9618 syllabus.
Actually, let me pause right here, because this brings up a massive examiner alert directly from the Principal Examiner Reports for the Input and Output of Data module. The report explicitly and repeatedly states that candidates consistently confuse key terminology. When you are writing an extended response, do not ever assume the examiner knows what you mean or that they'll give you the benefit of the doubt. Always define your terms before you use them to justify your extended response. For example, if you are discussing a specific data buffer, an interrupt, or a peripheral polling method, define what that means in the context of the scenario first. Doing this instantly proves your conceptual mastery, and it locks in those foundational marks before you even begin your deep analysis. It's a total power move.
And this brilliantly illustrates how we apply practical programming skills to these concepts. The syllabus demands algorithmic thinking, which requires a highly disciplined step-by-step approach. You must decompose the problem, select the appropriate data structure for your input and output, implement efficient code or pseudocode, and then rigorously test it. Look at these 4 steps on the screen. Let's do a quick mental exercise. If you were given a scenario where a temperature sensor is inputting data every single second to a microprocessor, how would you decompose that? What specific data structure holds that continuous non-stop input? An array? A queue? Mentally rewriting your approach to fit this exact algorithmic thinking blueprint is exactly how you separate yourself from the average students and achieve an elite grade.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Section 3. Critical Evaluation Mastery Workshop. So getting back into it, the absolutely crucial point of this module is data interpretation. Let's initiate Challenge 1, the data scan. On the screen, you see the core skills you need to master: extracting from binary representations, performing the necessary calculations, and drawing evidence-based conclusions. Imagine sitting in the exam and you turn the page to find a highly complex data table mapping the binary output of an automated control system. A lot of students freeze, but top candidates, they don't panic when they see a massive wall of ones and zeros. They flow like water. They systematically scan the table, isolate the exact relevant byte, convert it, and calculate the intended output. Then they draw a conclusion based strictly on the evidence in the data. Not on a random guess, not on something they memorized from a textbook, but on the data in front of them. Practicing this kind of rapid, precise data extraction is exactly what builds your exam day stamina.
Next up is Challenge 2, Find the Flaw. I want you to look at this evaluation table covering time complexity, space complexity, edge cases, and the overall effect on performance. Top-scoring candidates demonstrate elite evaluative thinking by considering multiple solutions and actively analyzing the trade-offs. Let's say a student writes a massive paragraph claiming their new input sorting algorithm is absolutely perfect, but they completely fail to acknowledge the space complexity limitations, or worse, they ignore the edge cases, like what happens when the input data is totally null. If you do that, you lose critical evaluation marks. You must be able to identify the flaw in your own solutions and explicitly state the limitations and their resulting effect on system performance. That is how you show genuine, critical, high-level analysis to the examiner.
Okay, let's dive into Challenge 3, the speed writing challenge. Listen, In the exam hall, time is your absolute greatest enemy. You need to be able to draft a perfect, evidence-justified paragraph in mere moments. I want you to mentally picture that Peel framework again. Point, evidence, explanation, link. Got it? Okay. If the command word is evaluate the use of an SSD over an HDD for a high-speed data logging input system, you have exactly 30 seconds to mentally draft that response. Ready? Go. Point. SSDs offer significantly faster read and write speeds. Evidence. They have no moving parts, unlike the magnetic platters of an HDD. Explanation. This technological difference allows for the rapid buffering of high-frequency input data without mechanical latency. Link. Therefore, it perfectly satisfies the high-speed data logging requirement of the given scenario. Boom. That structured rapid-fire speed writing is exactly what Cambridge examiners are desperate to read.
Section 4. Top examiner warnings. Let's get serious for a minute, because these aren't just guesses. These are sourced directly from the Cambridge Principal Examiner reports. Let's look at the top 3 mistakes candidates make in the input and output of data module. Mistake number 1. Examiners report that students constantly confuse cause and effect. They mix up what actually triggers the input and what the resulting output is within a control system. You have to keep your logic flowing in the right direction. Mistake number 2, students completely forget to check boundary conditions and edge cases. Think about it. If you design an algorithm for input, what happens when the input is exactly on the maximum physical limit? What if the input is 0? If you don't test the edges, your algorithm is fundamentally flawed. And mistake number 3, answers are not specific to the context given. As we learned with our persona Alex earlier, just dumping memorized facts without applying them to the specific scenario in the question prompt will literally earn you 0 marks. You must link your technical knowledge directly to the context, every single time.
Now, to ensure you don't fall victim to exam day panic and make those mistakes, here is a really powerful memory hack. The syllabus for instruction groups, specifically input and output of data, is incredibly dense. There's a lot to remember. So create your own custom mnemonics using the first letters of key terms to anchor these concepts deep in your brain. Whether it's a funny phrase to remember the exact steps of the fetch-execute cycle or an acronym for the different types of data buses, having that mental trigger gives you a solid, structured starting point when the pressure is on and your mind goes blank. It helps you rapidly recall the precise terminology the examiners are looking for, ensuring you define your terms accurately every single time without breaking a sweat.
And this brings us to a very important number on the screen. 2. This is the social proof directly from our data. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. That is literally the difference between sitting at a C and jumping up to an A. But remember, this transformation only happens if you are putting in the reps. You have to train in the dojo. You have to use the Peel framework, deconstruct those command words, and actively hunt for those edge cases.
Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by.
Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. And remember, when that exam paper is placed in front of you and the context is completely unfamiliar, don't crash against the problem. Flow like water, adapt your logic, and you will find the solution. Thank you for joining us on this explainer. Keep practicing, and I'll see you in the next session.